Hey, what's up, chem peeps? Let's take a quick look at an average rate of a reaction problem. Consider this balanced chemical equation. Boom! In the first 10.0 seconds of the reaction, the concentration of iodide ion dropped from 1.000 molar to 0.868 molar. Calculate the average rate of this reaction in this time interval. Okay, so let's think about how we're going to define the rate of this reaction in terms of the change in concentration of the iodide ion over change in time. Notice that we're going to divide our concentration of iodide ion by 3, or multiply it by a factor of 1/3 to determine the rate of the reaction. Then all we have to do is plug in the change in concentrations over the change in time. A quick jump to your calculator should get you a rate that is equal to 4.40 times 10 to the minus 3 molarity per second for this reaction. All right, so it's important to think about how we define rate in terms of the other reactants and products. It's important to keep in mind that as we define the rate in terms of each of the individual reactants and products, that we need to divide by the coefficient in the balanced chemical equation for each of those respective reactants or products. Now, even though this problem only asks you to determine the rate of change in the concentration of hydrogen ion, I'm going to solve for the rate of change in the concentrations of each of my aqueous reactants and products to give you a better understanding of what we're trying to get at when we determine average rate of reaction and how we define it in terms of the different reactants and products. And it's important to note that we've already determined the rate of the reaction based on the change in concentration of the iodide ion. So let's first determine the rate of change of the concentration of the hydrogen peroxide. Note that it has a coefficient of 1 in the balanced chemical equation. So if we know the rate of the reaction is 4.4 times 10 to the minus 3 molarity per second, recognize that the rate of consumption of the hydrogen peroxide is also going to be 4.40 times 10 to the minus 3 molarity per second. All right, now let's take a look at the rate of consumption of the iodide ion. Remember, we determined the rate of the reaction to be 4.40 times 10 to the minus 3 molarity per second. Therefore, the rate of consumption of the iodide ion is going to be 3 times that rate because we have that coefficient of 3. So notice the rate of consumption of my iodide ion is 3 times the rate of the reaction. All right. Finally getting to answer the question that's actually in your notes. Determine the rate of change of the concentration of the hydrogen ion. Again, we know the rate of the reaction to be 4.0 times 10 to the minus 3. Focus in on your coefficient in front of the hydrogen ion in the balanced equation. Recognize that the rate of consumption of the hydrogen ion is going to be double that, or 8.80 times 10 to the minus 3 molarity per second. And then finally, as we think about defining the rate of change or the rate of formation of the triiodide ion, the coefficient in the balanced chemical equation. We know the rate of the reaction is 4.4 times 10 to the minus 3. The rate of production of the triiodide ion is going to be equal to that due to that coefficient of 1. All right, so hopefully this video helped you better understand how we define the rate of a reaction and how the rate of consumption of your reactants and rate of production of your products are related to the coefficients in the balanced chemical equation. As you look at the rate of consumption of our hydrogen peroxide, iodide ion, hydrogen ion, and triiodide ion, recognize that the iodide ion is going to be consumed at 3 times the rate of our hydrogen peroxide, hydrogen ion at twice the rate, and the production of our triiodide ion is going to equal that of the hydrogen peroxide. And if you divide each of those rates of the reactants and the products by their coefficients in the balanced chemical equation, you will get the average rate of the reaction. And we are done.